Hi students, good morning everyone. Welcome back to today's class. In our previous class, we have discussed the quartile deviation, right? So we have seen quartile deviation for the ungrouped data. So under measures of central tendency, so there are four measures, right? So the first one is range. We have completed range. The second one, we have studied about the quartile deviation. So what is quartile deviation? Quartile deviation is the half of the interquartile range. So what is interquartile range? The difference between the upper quartile and the lower quartile. So upper quartile means Q3, lower quartile is Q1. So the difference between these two quartiles is called interquartile range. So half of the interquartile range is 1/2 of Q3 minus Q1 is called as the quartile deviation, which is also known as the semi-quartile range. So for the quartile deviation for the ungrouped data. So ungrouped data, we are going to have only the variables, the different values of the variable. So for this, how we will be finding the quartiles? Q1 will be the n plus 1 by 4th term. So after arranging the data either in the ascending order or the descending order, Q1 is calculated by the n plus 1 by 4th term. Similarly, Q3 is calculated by 3 into n plus 1 by 4th term. So in the ascending order, Q3 is the 3 into n plus 1 by 4th term. So after getting Q1 and Q3, the quartile deviation, which we denoted as QD, is equals to Q3 minus Q1 divided by 2. So this is the formula for the quartile deviation under the ungrouped data. Now we will see a small problem. So for the ungrouped data case, we will see a small problem. So find the quartile deviation for the values. Find the quartile deviation for the values. So the values are given as 2, 4, 10, 8, 6, 12, 5. 6, 12 and 5. So how many values are given here? So total 1, 2, 3, 6, 7 values are given. So first write down the n value. So here n equals to 7. So what is the value is 7. So 7 plus 1 by 4th observation. So 7 plus 1 is 8. 8 by 4 is 2. So Q1 equals to second observation. So if you observe in the ascending order, what is the second observation? Here, this is the first observation. This is the second observation, that is 4. So second observation equals to 4 is the first quartile, that is Q1 equals to 4. Next, similarly, we will be finding the Q3 value. What is Q3? Q3 equals to 3 into n plus 1 by 4th observation. So substitute the n value. What is the n value? 7. So Q3 equals to 3 into 7 plus 1 by 4th observation. So in this term, 8 by 4 is 2, 2 into 3 is 6. So 6th observation is the third quartile. So Q3 equals to 6th observation. So in the ascending order, what is the 6th observation? 1, 2, 3, 4, 5, 6. So here 6th observation is 10. So at the 10 you are going to get the third quartile value. So Q3 equals to 10. Now you got Q3 and Q1. Substitute this Q3 and Q1 in the quartile deviation formula. So hence the quartile deviation is given as QD equals to Q3 minus Q1 divided by 2, which is equals to, what is the Q3 value? 10 minus Q1 value is 4 divided by 2. So 10 minus 4 is 6. 6 by 2 is 3. So therefore the quartile deviation, for the given data is QD is equals to 10 minus 4 is 6, 6 by 2 is 3. So quartile deviation is 3. So in this way we are going to find the quartile deviation. So whenever ungrouped data is given, remember that first you need to arrange in the ascending order. Then you have to find the Q1 and Q3 values. So how to find the Q1 value? N plus 1 by 4th observation. So what is N value? N is the number of observations given. So if there are 6 observations given, you will take N value as 6. If 7 observations are given, you will consider the N value 7. So like that. You will be finding the N plus 1 by 4th observation. So in this, you will be getting at which place you are getting the first quartile. So here we got second observation. So what is the second observation in the ascending order? 4. So 4 is considered as Q1. Similarly, Q3 means 3 into N plus 1 by 4. We got the 6th observation as the third quartile. In the ascending order, what is the 6th observation? 6th observation is 10. So we got the Q3 value as 10. So by substituting Q3 and Q1 values in the quartile deviation formula, we got the required quartile deviation as QD equals to 3. So in this way, we are going to find the quartile deviation for the ungrouped data. So now we will see how to find the quartile deviation for the group data. So in group data, we will be having the different frequencies. So here how to calculate the quartiles? Quartiles are similar to median, right? So in the same way how we have done the median, we are going to find the quartiles. Now we will see the formula for the is QD equals to Q3 minus Q3 minus Q1 by 2. So the formula will be same, but the way you calculate the Q3 and Q1 values will be changing. So how we will calculate the first quartile? So quartile deviation for group data. Under group data, first and third quartiles are calculated by. So first we will calculate the first quartile. So first quartile is denoted with Q1, right? So Q1 is equals to L1 plus N by 4. So N by 4 minus C1 divided by F1 into H1. So what is the description of this formula? Into H itself, the class interval will be same for all the classes. So now what is L1? So for this also, first we have to find the quartile class. So how to find the quartile class? So quartile, for finding the quartile class, first we need to calculate the N by 4 value. So after calculating the N by 4 value, so we will be checking in the cumulative frequency. So same like median, for quartiles also, we need to calculate the cumulative frequencies. So in the cumulative frequency, so whichever the value you get just greater than N by 4, that corresponding class is considered as the quartile class. So for quartile class, you need to calculate N by 4 value. In the cumulative frequency, wherever you get the cumulative frequency just greater than N by 4, that corresponding class is considered as the quartile class. So after calculating the quartile class, you will be considering the lower limit, that is L1, that is the lower limit of the quartile class. Lower limit of quartile class. Similarly, what is F1? F1 is the frequency corresponding to the quartile class. So here you write lower limit of the first quartile class. Frequency F1 is the frequency of the first quartile class. Frequency of the first quartile class. Similarly, what is C1? C1 is the cumulative frequency of the preceding. C1 is the cumulative frequency of the class preceding the first quartile. Cumulative frequency preceding the quartile class. So after getting the quartile class, the before cumulative frequency. So if suppose 10 to 20, 20 to 30 is there, if 20 to 30 is the quartile class, so before that, preceding that, 10 to 20 is the class. So corresponding to the 10 to 20, whatever is the cumulative frequency, that is considered as the C1 for the quartile. Preceding the first quartile class. So this is the description, and one more thing, H. What is the H? Width of the quartile class. H is the width of the quartile class, or you can write scale. So in this way, we are going to find the Q1 value. Now, similarly, the third quartile. So third quartile is denoted with Q3, right? So Q3 equals to N3 plus, here instead of N by 4, we will be considering 3N by 4. by 4. Just greater than means immediate next value of that 3n by 4 value is considered as the quartile class, that is third quartile class. This is considered as the third quartile class. So after getting the third quartile class, the procedure is similar. L3 is the lower limit of lower limit of third quartile class. Next, similarly, what is F3? F3 is the frequency of the third quartile class. Corresponding frequency of the third quartile class is called the F3. And similarly, what is C3? C3 is the cumulative frequency preceding the third quartile class. And similarly, H is the width of the class, that is quartile class, which can also be called as the class interval, width of the class interval. Frequency of third quartile class. Similarly, this is the cumulative frequency preceding third quartile class. Now after getting the Q1 and Q3 values, then the quartile deviation is given as, the formula is same, that is QD equals to Q3 minus Q1 divided by 2. Only the way of calculating Q1 and Q3 is different for the group and ungrouped data. The formula for the quartile deviation remains same. Now we will see a problem on calculating the quartile deviation for the grouped data. So here group data means the class intervals and the frequencies will be given. That is the continuous series. So same like median, the procedure will be same for the quartiles also. So if you get the median thoroughly, if you practice, then you can calculate the quartiles easily. Coming to the question, find the quartile deviation to the given data. So here the data is grouped data and a continuous series. So class intervals and the frequencies are given. So class intervals are 0 to 20, 20 to 40, 40 to 60, 60 to 80 and 80 to 100. And the corresponding frequencies are given as 10, 25, 40, 50 and the last 10. So for calculating the quartiles, what is the first step we need to do? We need to calculate the cumulative frequencies. So first calculate the cumulative frequencies. So how you will calculate the cumulative frequency? By adding up the frequencies up to the particular value, we are going to get the cumulative frequencies. So first value we will be writing as it is. So that is 10. Next 10 plus 25 is 35. Next 35 plus 40 is 75. 75 plus 15 is 90. 90 plus 10 is 100. So what H. So for this, we need to first get the quartile class, that is first quartile class. So for finding the first quartile class, we need to calculate n by 4 value. So what is n value? 100. 100 by 4 is 25. So now in this cumulative frequency, what is the value just greater So just greater than 75, what is the cumulative frequency? 90. Just greater than, after 75, what is the cumulative frequency? 90. So corresponding to 90, what is the class we have? 60 to 80. So this 60 to 80 is the third quartile class. That is Q3 class. Now write down the different values whatever we need. So first L3. So here the quartile class is, third quartile class is 60 to 80. So what is the lower limit of this class? The lower limit is 60. So L3 equals to 60, comma. Next F3. F3 is the frequency corresponding to third quartile class. So 60 to 80 corresponding to this quartile class, the frequency is 15. So this 15 is the F3 value. So F3 equals to 15. Next C3. C3 is the cumulative frequency preceding the third quartile class. So 60 to 80 is the third quartile class. Preceding means 40 to 60. So corresponding to 40, 60, what is the cumulative frequency? 75. So this 75 is the C3 value. Next H. H is 20 itself. That is the length of the class interval or the width of the class interval. Now substitute all the values in the Q3 formula. So Q3 equals to L3, that is 60 plus 3n by 4 value is 75 minus C3 value is also 75 divided by F3 value is 15 into 20. So 75 minus 75 is 0. So 0 into anything is 0 itself. So 60 plus 0, the third quartile value is 60 itself. So Q3 equals to 60. And what is the Q1 value we got? Q1 value we got it as 32. So the quartile deviation is given as, the quartile deviation is given as, so we denote the quartile deviation with QD. QD equals to Q3 minus Q1 divided by 2. So what is the Q3 value? 60 minus 32 divided by 2. 60 minus 32 divided by 2. So 60 minus 32 is 28. So 28 divided by 2 is 14. So therefore quartile deviation equals to 14. So in this way we will be finding the quartile deviation for the ungrouped and the grouped data. So in the next class we will be seeing the different merits and demerits of the quartile deviation, and also we will start